Thank you so much for coming. Welcome to Modze's Friday Tech Talk. Today we're going to be talking about running AI models at the edge, and I've got a bunch of cool stuff to talk through and go through and show you. So let's not waste any time. Let's get going. So a couple things for those of you who may have not been to a Tech Talk before. Welcome. We're so excited to have you. We do these every Friday just to provide an opportunity to spend 30 minutes with other members of the AI, ML, DevOps, software development world, talking about different topics related to artificial intelligence, operationalizing it, running it, using it in the real world. So we do these every Friday, start at 1 p.m. Eastern, and we're gonna do 52 of them this year. So you can always come by anytime at 1 p.m. on a Friday and find us here. If you'd like to join the talks live, just join this channel, again, 1 o'clock any Friday. And then after each of our tech talks, we'll typically just jump over to the general voice channel for an open discussion. So if there's something you're interested in following up on, questions, feedback, we'll all be over on the general channel to chat afterwards. Couple talks that we've done earlier this year you might find interesting. We've done some things, everything from an introduction to model ops to an overview on AI hardware, using Modzie with Tableau, crash course to gRPC last week from Ray, which was awesome, by the way, and I learned a ton. You can find all of these on YouTube. We record all these tech talks and then just put them up on YouTube so they're available for folks to look at it in case they're not able to join in real time. And so if you go to the links channel, under our YouTube link, you can find all of our past tech talks. So definitely recommend checking those out. All right, enough background fluff. Let's get going. So running AI models at the edge. To unpack this statement and figure out what the heck that means and what can we do with that, I want to actually go back to the beginning of modern computing to think about what the term edge really means. And I'd encourage you to think about edge computing less as a concept or as a specific physical device, and more as a measurement of where computing is happening. The location of the actual addition and subtraction and multiplication and division of binary numbers, where is that happening? So if we go back to the early days of really analog computing and early digital computing, where everyone's working on mainframes, the paradigm is basically that you got an individual user who's typing a bunch of stuff in through their terminal, through a console, that's then connected to a mainframe. So in that early era, all of the computing was done in a central way. There might be multiple terminals connected to that mainframe computer, but they're basically data input machines. So there is no local computation. It's all done centrally. Now, sort of the next era that we see emerge was the PC era. And I do realize it's ironic that I'm calling this the PC era, and I have a little Macintosh, Apple Macintosh computer screen, but that was the best logo I could find. So we're going with it. But in the PC era, we start to see the emergence of home computers that have a lot more horsepower, to such a degree that you're actually able to start doing computing at home locally. And one of the other reasons why local computing ends up being a lot more efficient in this PC era is that network transmission is pretty slow. So even though there are servers out there, you're getting the beginning of the internet and the World Wide Web, you have to go over a phone line. And even if you're sort of past phone line internet, DSL is still a while away. So because the network traffic is so slow, local computing starts to win out. So we went from central computing to more of a local computing-based model. Now enter the mobile era. At this point, we now have access to cloud computing. Server hosting has really been centralized to just a few key players. And smartphones are the number one sort of most commonly internet connected device. So in this mode, because internet speeds have sped up, because there's this consolidation of cloud providers, we start to see the reemergence of this central computing model, where a bunch of different edge devices, these smartphones we all have in our pockets, are communicating to the cloud and are offloading a lot of the more complicated, heavier lifting to the cloud, and then waiting for those sort of results to be returned to the device. Now enter the edge era. We've gotten to a point where there are so many internet-enabled devices, all operating sort of in different modes and different paradigms, still needing some connectivity to the cloud. It's created this really complicated tableau of devices and cloud providers and edge nodes and sort of on-network systems and off-network systems all trying to talk to each other to the point where it's just crazy. And this is what edge computing is all about, figuring out how to take advantage of all of these different computers. At the end of the day, they're all just a bunch of computers talking to each other, and figuring out where should the processing happen. And depending on the type of device and the use case and what you're trying to do with that device, it can be an open question. So that's where we are today. Now, AI at the edge specifically, why is AI at the edge important? Why is this a topic that is getting more interest and focus? Well, really 3 reasons why you'd want to run artificial intelligence, or you might call it machine learning, at the edge. One is for security. So one of the best ways to have a very secure network is to have a computer that's not connected to any network whatsoever. For those of you who are Battlestar Galactica fans, you'll know that General Adama smartly disconnected all of the computer systems aboard the Battlestar Galactica, allowing the defense against the Cylons to make progress, and that is why their ship survived the initial Cylon attack. So if you want a very secure computer, disconnected from the network entirely, and you have a lot fewer vectors of attack to deal with. So that's one potential value. Secondly, latency. When you're working with really large data sets, or if you're working with data sets in a sort of remote location, the latency at which these models make their predictions can have a big impact. So being able to move the computation on computer vision, images that are coming through a computer, on audio data, on signal data, especially if you're using, let's say, machine learning for signal processing of encrypted radio signals. The latency can be so slow that things start to really break down. And this is particularly true as we begin to experiment with, as sort of a technical community, the use of machine learning with augmented reality and virtual reality. If you've ever been in virtual reality, you know how devastating a single dropped frame can be. It totally messes up your brain. So in those scenarios, latency ends up being the most important reason why you might want to run a machine learning model right on a physical device and not send that data up to the cloud. And then the third big reason is for network availability. Take, for instance, a smart car. If you have a Tesla that's in auto mode and you're driving through the mountains of Idaho and you lose network connectivity, you don't want your smart car to lose its ability to drive itself. So the necessity to be able to do onboard computing and decision making is really important from a safety standpoint. So each of these factors are potentially one of a few reasons why you might decide to move your AI and your machine learning to an edge device. Now, a few common use cases that you might have heard of before where edge AI is getting a lot more popular. So one is in the use of smart cameras, being able to do real-time computer vision analysis right on cameras themselves. So most of us who have Nest or Ring doorbells have probably seen this before, where it can identify if there's a person by your door or versus a dog or a car. It maybe won't let you know that there's someone standing there. Another space we're starting to see more local processing is on our smartphones. Apple in particular has invested a lot in building custom chips, custom hardware, that allows you to do local AI processing at pretty fast speeds. So the types of models that historically you would have needed to run in the cloud because smartphones didn't have the power to run them, you can actually now start running more and more of those models on a local smartphone. Autonomous vehicles, again, another great use case for running models locally. And then just general computer vision across the board for baby monitors, running it on drones, robots, other local machinery, where that latency could cause a lot of performance issues. These are some common spaces where you might want to use AI at the edge. Now, you might see here that there's a lot of variation in the kinds of devices that qualify as edge devices. Quite frankly speaking, you could think of edge as just sort of distance, and I'll use that term very colloquially, distance from the cloud. Distance could be in one of two forms. It could be based on the sort of expected network connectivity between a device and the cloud or your server farm or your home network. So, for instance, you might have an off-grid server, a tactical server that's running in an oil field somewhere, or supporting some NGO out in the field. You might have a ton of power, but it's effectively an edge device because it really cannot have a consistent, reliable communication back to the cloud or some central hub. Alternatively, another axis at which you can sort of measure, evaluate, and compare devices is based on their power needs and their kind of power consumption. So, looking at things like a Raspberry Pi or a drone or a microcontroller, these are devices that are very low power and really can only offer a limited set of computing functionality at their particular location. And so if you kind of map this all out, you can think of things in terms of near edge and far edge. But there's also another way to look at or categorize edge devices and how we might want to use them. And that's in terms of sort of two segmentations that I call the segmentation of speed and the region of reliability. So generally speaking, you're optimizing for one of two things, either speed, high performance, low latency, in which case you want to try and make sure that you get the most powerful model you can out to the edge device, because you need the predictions from that machine learning model to get generated super, super, super fast. So, a 5G mech and a smartphone, you might not think of these as edge devices in the traditional sense, but realistically, we're working hard to try and move as much machine learning power to these types of devices, even though they have relatively reliable and typically pretty good connectivity back to the World Wide Web, to the internet as a whole. And at the same time, Raspberry Pis and Jetson Nanos, you might think of these as more traditional edge devices, but they tend to have great network connectivity as well. You tend to use these in scenarios where you want to have something that you can use a Bluetooth connection back to the internet to automate maybe some home automation project. The important part here is for speed versus reliability. Devices like microcontrollers, which have no operating system, tactical drones, your smart car, we talked about that before. These are scenarios where the reason you're treating it as an edge device is because it has to do its job pretty effectively, even when you lose that network connectivity. So, these are kind of the two paradigms through which, we at Modzie look at this edge environment and sort of how we break down the use cases and the actual physical infrastructure needed to execute these different types of tasks. So, as we started looking into this challenge, we put together kind of a wish list of what would be a great experience for being able to effectively use machine learning on all of these types of devices for all of the use cases we talked about. So we came up with kind of 5 items. One was, it'd be great to have a reliable way to get ML models and all their dependencies, all the frameworks and libraries and pre-processing and post-processing code, all that stuff onto another device. Second one, it'd be great to have a way for those ML models to then run the same way on different types of devices. And this can be tricky, especially when you look at different CPU architectures, the availability of GPUs in some cases, the availability of really special hardware in other cases, like Apple is known for building a lot of their own custom silicon. It ends up getting very complicated. If you want to go on a deep dive on that, we actually have a tech talk on exotic AI hardware, which would definitely encourage you to check out. But it's complicated, and to be able to run models the same way across all these devices and let those models use whatever hardware is available would be awesome. Third, it'd be great to have a way for models to then talk to the local sensors on those devices so that you can get really quick input-output right from that local device to the model, with the inference results returned back to that device super fast. The fourth would be a way to get those outputs and make them easily accessible in order for you to do something with them on that device. And then finally, it'd be awesome for these models to be able to keep running, keep doing their jobs, even when the internet is unstable. And that's really to help support those use cases where reliability is the main driver. So what we came up with is a new feature set we just rolled out this month called Modzie Edge. And we're going to do a quick demo of it for you today, kind of a crash course into it. But the concept essentially is that we've added a new set of features within our Modzie platform that allows you to create, configure, and manage groups of edge devices. And in a nutshell, let you choose 1, 10, 100 models that you'd like to then remotely deploy to edge devices anywhere in the world. So you can have your edge operations somewhere in North America, but you can be sending machine learning models to run all over the world. And it's designed in such a way where we can support Intel, AMD, ARM devices, devices with NVIDIA GPUs or without, a range of operating systems. And we offer the same API layer that our typical Modzie in the Cloud product offers right on these small edge devices. So the next thing I want to do is actually just go into a demo and show you what this thing is all about. All right, we'll close this up and jump on over to Modzie. Okay, so I'm going to go over and just show you an example of a model. So within our product, in case you're not familiar with Modzie, we have a cloud-based model ops platform that lets you package up your machine learning models, run them in the cloud, and basically interact with them through a really simple API, both REST and gRPC. So if I want to go ahead and just run a quick test of this model, I'll mention that today is a beautiful day in Northern Virginia, where I am based at, and I'll put a little exclamation mark. So this is a simple sentiment analysis model, and what we're doing here is just sending it a simple input. Modzie is spinning up an instance of this model. Oh, I forgot to use the instance I'd stood up. My apologies here. We're in this wrong model. So this basically takes in a simple input, processes it through a sentiment analysis model, and then will return a prediction. In this case, it's predicting the happiness or sadness of my little piece of text. So the analysis here is that it's mostly neutral, but neutral with a lot of positive. So that's generally a positive result. So this is great. This is helpful because you can use this within other web applications, mobile applications. Again, scenarios where sending data to the cloud and waiting for a result isn't going to be an issue. Now that's awesome for a lot of scenarios, but in all those edge cases we talked about, what if you want to run this model right on your edge device? You want to run it on your Raspberry Pi for a cool little art project. How do we take this model and actually make it usable on some of these other edge devices? Well, the answer is through our Modzie Edge Devices feature. What we're going to do here is create a new device group. So I'll just create one here for our little Discord demo. And we're going to go ahead and just walk through the process of what this would be like if you wanted to set this up to run models on a bunch of Raspberry Pis, some computer vision, Jetson Nano accelerated cameras, on a fleet of vehicles, on physical devices inside a factory. You'd follow the exact same process. So we'll go ahead here and name that group. I'm going to select that sentiment analysis model we were just looking at. So I'll grab that sentiment analysis model. I actually want version 1.1 because I just happen to know that it's better than 1.027. And I'm going to give it 2 processing engines, which basically means you can run up to 2 copies of this model anywhere in the world. So I'll go ahead and create this device group. And now that should show up somewhere over here. Here we go. All right, Discord demo edge group. So we've got this group. What does that mean? Well, it means that now we have this model sentiment analysis that will automatically get sent to any device you connect back to Modzie. So I want to connect my laptop just for the sake of this demonstration. The way we can do that is by creating a device token. And this allows us to essentially, from a remote device, call back to Modzie and say, hey, hook me up to the Discord demo edge group and give me all the goodness that's been set aside. So I'm going to go ahead and create a little token here. It'll expire in 9 hours. We'll use it 10 times. And I'm going to go ahead and create that. So what we've done now is created the ability for us to connect back to this central instance of Modzie and download this model for us to use locally. What I'm actually going to do to make this even easier is I'm going to get the instructions that I can use to basically connect to this model. I've already downloaded and installed Modzie Core on this machine, so I don't have to worry about these top 2 commands. So it's basically just one command right here. And we'll talk through this in just a second after I copy it. So I'll go ahead, download that key so I got it for later. And now we're going to go over to terminal. I just have here in my code editor. And we're going to go ahead and paste this in here. So what's happening here? We're essentially calling a small little binary called Modzie core and asking it to serve a model that it's going to receive based on the token here that's getting sent to Modzie. And this little token is going to tell Modzie which device group this device should get connected to, and then we'll automatically start downloading the models that belongs here. So go ahead and run that, and then we're going to get a ton of fun data downloading happening. And downloading data is always a lot of fun to watch happen in real time. So I'm going to jump on over to another window real quick while we're waiting for my internet to do its thing. Just to show you, Docker, which is what we use to actually essentially run the containerized models, has got nothing in it right now. There's no containers or apps or images. But by the time this download process is complete, what's going to happen is that the sentiment analysis model that we called out here is going to be downloaded and start running right on my local machine. And not only is it going to start running, it's going to start running wrapped inside of Modzie's API. So I can actually start interacting with that model using the same APIs that you can use when Modzie is up in the cloud. So we'll head back here to Visual Studio, just see how well it's going. I'm seeing the bar getting close to the finish line, which is always fun. And then there's some other bars. I'd lie if I told you I knew exactly what's happening in all of these steps. But the head of our engineering team, Nathan Mellis, and the head of our backend squad, Ray Vargas, do know what's happening here. So if you have detailed questions on what's being downloaded and configured, ask them the tough questions in our chat. Okay, there we go. So the model is downloaded, and what I can see here is that the server is listening at port 55,000. All right, so recap. We created a device group. We created a token to connect to that device group. And then we just connected my MacBook Pro here back to that device group. So if everything worked out correctly, we should be able to start running inferences on my local machine. So let's try and see if that works. I'm going to go over here to Postman, and I'll just show you an example job that we're going to send to this sentiment analysis model. This is the ID for the model that we downloaded, and this is the specific version that I called out. I wanted to use 1.0.1 because I like that one better. And we're just going to send it a quote from Battlestar Galactica because for whatever reason, BSG has been on my mind today. So we'll go ahead and send this right here to my local IP address to port 55,000. And we'll see what happens. Sending the request. And there we go. The job was successful. And now if we go back to look at our terminal, we can actually see that it completed in less than a millisecond. So we talked about latency before as being important. Running models on your edge device is one of the best ways to get crazy low latency. So if we want to take a look at the results, we can use Modzie's API to actually query the results. But we're doing it from, again, my local laptop here. So I'm going to copy this job identifier that processed this input, and we'll go ahead here and get those sentiment analysis results. Just got to paste that here. Again, if you're writing an application, you can do this with whatever API interaction you'd like. We have SDKs to make this really easy. I'm just using Postman here because it's kind of simple to use for a demo like this. So here we see the data that was submitted, this Commander William Adama quote. It was completed. We can see the start time and the end time. We're very close to each other because it happened fast. And then we can see the class predictions for this text were mostly neutral and then a bit negative. And the quote is about basically police brutality. So that seems like it was on point. So this is all awesome news. And what this means is that we were able to successfully take that model, download it to my local machine, start the model up and running wrapped in Modzie core, and then start interacting with it via API. Now, if I go back over here, back to Modzie, I should be able to go to the devices list, and we can see here is the device, my local machine, that was connected to this group. And here you can see my IP address right here, and the port number that it was assigned to is available here. Better yet, we can actually see, we'll go back here to my little Discord group I created. There we go. We can actually see someone else, while I was talking, connected their device to it as well. So head of our engineering team, Nathan, behind the scenes, he also connected to the same device group, just to show that his laptop in California and my laptop in Virginia are both able to access the same model, the same device, and execute that same function. And if we head over to Docker, just to show you that this isn't a total mumbo jumbo, we can actually see here's the container of that little sentiment analysis model that we downloaded and started hosting. So this kind of concludes the demo I wanted to share. At this point, I'll go back to the slides briefly just to talk through conceptually what we did here and why we think it's so exciting. But within Modzie, we went ahead and created a device group here that allows you to connect to really any type of device that's capable of running Docker, which covers the majority of edge devices for most domains, really with the exception of smartphones. That's one of the areas where we're continuing to look at other compelling ways to get models that can easily run on smartphones. But aside from that dependency, you can essentially define a group of one or more models that you'd like to run on those devices, and then run 3 commands at most to remotely deploy those models to an edge device. Modzie again runs on Intel, ARM, AMD. You can use GPUs, and once you complete that download and run process, all of the models you've downloaded locally are hosted through our little model server, and then you can start interacting with them right through our API, which sends the requests right to each model and then returns those inference results, which you can use to process on-device sensors, or you might use as just a sort of a local server node, maybe one central machine for all of the nearby drones that you want to use for processing. Just a few examples. Now, coming up in about a month, we're going to have some real-world examples of this, not running on a MacBook Pro, that we'll be able to show you, that I think are going to be pretty fun. We've got one lined up that we're planning to show off. Let me stop streaming here for a sec. Where we're going to be doing some sensor data analysis using machine learning to automatically classify air quality, running that on a little Raspberry Pi. And then we're going to be doing a computer vision example on a Jetson Nano. So we'll show you kind of more of an end-to-end example of once you've done this process of taking a model, deploying it to an edge device, how do you actually interact with it and build a more fully featured application that's actually using that model to do something real, to do something meaningful, to do something interesting at the edge. So I cannot wait to have you guys back for that one. We'll have some cool things to show you then. And Brett and Sawmill, who are working on those demos, I think are going to knock your socks off. So that's everything I had for today. Thank you guys again for joining. This was just a delight. Thanks for letting me talk at you and make nerdy references to Battlestar Galactica. Really, I couldn't ask for a better Friday. So with that, I'll wrap things up. But if anyone's interested in chatting more, got questions, got some other ideas to share, we'll be over in the general voice channel. So hope to see you there.